Let's solve this problem using the knowledge of quadratic relations and geometry. A farmer has 200 meters of fencing and wants to fence off a rectangular fence that borders a straight river. What dimensions of the fence will give the maximum area? So let's quickly do a diagram for the river. So if that is the river, the field that's going to be built with the fence is going to be like this. So it's only going to have three sides. One of the sides is going to be the river. So we have a width and we have a length. And we do have to make two variable statements. So what I'm going to do is I'm going to say W. So let W be the width of the field. And L, let L be the length of the field. And since I have already assigned variables for the width and the length, I can write a general equation for the perimeter. So the perimeter of this rectangular field is going to be 2W plus L. So that's 2W plus L. And we've already been given the length of the fence, which is 200 meters. So that's going to be 200. So in 2W plus 2L is going to be equal to 200. Plus L is going to be equal to 200. So now what I'm going to do is I'm going to isolate L from this equation to be able to use that in my next equation that I'm going to write for the area. So 200, I'm going to move the 2W over to the other side, so it's going to become negative. So L is 200 minus 2W. Now I have to find the area, the dimensions of the field that would make the maximum area. So if I want to write the area of that field, which is going to be A, L times W. So areas is length times width. So that's going to be the equation. Now for the length in here, what I'm going to do is I'm going to replace that with this expression which has W, so that I can have an equation, an expression in just the variable W. So this L is going to be replaced by 200 minus 2W, and that's going to be multiplied by W. Let's multiply that by W. So that's going to be negative 2W squared. So that's going to be, I'm just writing the squared term at the front. And I have positive 200W. So what I have to do is to find the dimensions which would give the maximum area. What I actually have to do is write this quadratic equation in vertex form so that I can find the maximum or the vertex of the relation. So since this is a quadratic relation, it's going to be, and I have a negative sign, it's going to be opening down, and it's going to have a maximum, and that's the value that we are after. So let's do completing the square to find the dimension that would make the maximum area. So A is going to be equal to, since I have a coefficient in front of the squared term, I have to factor that out. So I'm going to factor out negative 2, and let's see what's left in the bracket. So it's going to be W squared, and that's going to become minus because I'm dividing by negative 2, and it's positive 200, negative 100 W. So that's going to be inside the bracket. Now, when I look at these two terms, I have to think about what I have to add to make this into a perfect square trinomial. So let's do that, negative 2. And since this is 100, so I'm going to take half of that, which is 50. And I'm going to square that, which is 2500. I'll be adding 2500 to these two terms. And I cannot just add 2500, I have to subtract because I can't make any changes. So just to keep it the same expression, I have to add and subtract. Now I'm going to be using these three terms to make up the perfect square. So let's do that. So -2, and I'm just going to group these so that you'll see that I'm going to be using that to make up the perfect trinomial. And this -2500 is going to come out of the bracket, but when it comes out of the bracket, it's going to be multiplied by -2 and then added to the expression. So when I multiply -2 times -2500, which is going to be positive 5000, that's going to go outside. So now positive 5000 is outside. Now I have the perfect the terms for a perfect square. Let's write the expression. So it's going to be W minus it's going to be W minus 50 squared and 5000. Now from this expression, I can get the vertex. So the maximum is going to be at 50 and 5000. So my 50 is the value of the width. So when W is equal to 50 meters, that would give me the maximum area. But I'm asked for both the dimensions, so I have to find the corresponding length. And I do have an expression for that. So L is equal to 200 minus 2W. So 200 minus 2 times 50, that's going to be 100. So 200 minus 100 would be 100 meters. So the dimensions that would make, that would give the maximum area of the field are, the width would be 50, and the length is 100. So let's write the final statement. Therefore, the dimensions of the field that would maximize the area are, width is going to be 50 meters and length is going to be 100 meters.